Let's look at an application of projectile motion using parametric equations. So in this example, we have a golfer and they're on the second floor of a multi-level driving range. And this golfer hits a golf ball and it has an initial speed of 165 feet per second. It has an initial angle of elevation of 35 degrees. So again, that's angle of elevation is 35 degrees from the horizontal rotating upwards, 35 degrees. And the initial height of the ball is 12 feet because remember they're hitting it from the second floor. So we want to write what the parametric equations would look like for the trajectory for the path of this ball until it hits the ground. So in general, when we have an initial height, an initial speed, and an initial angle, the parametric equations are always going to have the following form. The x value is going to equal the initial speed times the cosine of the initial angle times our variable t. So v sub 0 cosine of theta times t. The y equation is going to be y equals a negative 16t squared plus the initial speed times the sine of the initial angle times our variable t, and then plus the initial height. So y equals a negative 16t squared plus v sub 0 sine of theta times t plus h sub 0. Okay, and for the y equation, the negative 16t squared, if you study physics ever, if you take a physics class, that negative 16t squared is there because of gravity, right? Gravity is a downwards force pulling objects downwards. Okay, we don't have gravity in the horizontal direction, so that's why that negative 16 is only on the y equation. Okay, if we look at these two equations just before we write anything out, the x equation is a linear equation, a linear function, because it's just t, x of t. The y equation is going to be a quadratic function, so it's y of t squared. So whenever we look at, if we were to look at the graph of a projectile motion type problem, it's always going to be a parabola opening down because it's a negative t squared term. Okay, so to write the equation for this specific problem, we just need to fill in those two generic equations with the values that we're given. So we know x is equal to the initial speed times the cosine of the initial angle times t. So x is going to equal 165 cosine of 35 degrees times t. And the t is outside of the cosine. It's not cosine of 35t. It's cosine of 35. And then that's times t. So you could actually figure out what this 165 cosine of 35 degrees is as a decimal or as a numerical value and just put it in front of the t. Okay, I'm not going to do that here. I'm just going to leave it just for accuracy purposes. I'll leave it the way it is. All right, so to write the y equation, we know y is equal to a negative 16 t squared plus the initial speed times the sine of theta times t. So it's negative 16 squared plus 165 sine of 35 degrees times t, and then plus the initial height, which in this case is 12 feet, so plus 12. So that's my my parametric equation given an initial speed of 165 feet per second, an initial angle of 35 degrees, and an initial height of 12 feet. Okay, so the next part of the problem is we want to figure out when does this golf ball eventually hit the ground. Okay, and so when we look at our parametric equations, we have two equations. The x equation represents horizontal distance. So that's not going to tell me anything about when it hits the ground. Instead, I want to look at the y equation because that's giving me height. So what is the height of an object when it hits the ground, right? The height of an object when it hits the ground is when y is equal to 0. So I want to take my y equation and set it equal to 0 and solve for t. So we're going to have y equals 0, or 0 equals a negative 16t squared plus 165 sine of 35 degrees times t plus 12. Okay, so as you look at that equation, that is a quadratic equation, right? Because we have a t squared. We also have a t. So there are several ways that we could go about solving this. If you're using technology like Desmos or a graphing calculator, you could graph this quadratic equation and find where it hits the x-axis. So that's one way to do it. Be aware, though, that the x-axis is not the x-axis. It's actually t, because our function is a function of t. If the numbers turned out to be nice, you could try to factor this, but we have this sine of 35 degrees, and that's not going to factor easily. It's going to be hard to figure that out. So the other option that we could try is the quadratic formula. Okay, so if you remember the quadratic formula, x is equal to the negative b plus or minus the square root of b squared minus 4ac all over 2a, right? That's the quadratic formula. In this case, the a is our negative 16. The b is the 165 sine of 35, and c is our 12. So we got to plug those three values into the quadratic formula. So we're going to have x, but it's actually not x that we're solving for, it's t, right? Because my y equation is a function of t. So t is equal to the negative of b, so it's going to be a negative 165 sine of 35 degrees plus or minus the square root of 165 sine of 35 degrees. All of that is squared minus 4 times a negative 16 times 12. And all of that is divided by 2 times a negative 16. Okay, so that's what the quadratic formula looks like if we write it all out and type it into a calculator. And you're going to have to do this twice, right? Because you have the plus the square root and the minus square root. Okay, and so if we do that, we're going to get the two answers. One answer for t, one value that we get for t is that t could be a negative 0.12. And again, it's a longer decimal. I just rounded it to 2 digits. So we get a negative 0.12, or we could get a positive 6.04. Okay, so we're assuming in this problem that the whole problem starts at t equals 0 and goes forwards in time. Okay, so really talking about this negative value doesn't matter. It's actually if you were to go backwards in time when the ball would fall down and hit the ground, but we don't need that. So it's going to take 6.04 seconds for this ball to reach the ground from where we hit it. Okay, so now is the question that was asked: when will it hit the ground? So when you see the word when, that's a question of time. Okay, so when is a question of time. When it hits the ground, that's telling me I want to know the y value is 0. Okay, so when will it hit the ground? At 6.04 seconds. The second part of this question asks how far will it have traveled? So when I see how far, or a similar type of phrasing, similar type of words, I'm thinking distance there. That's not height, that's not time, that's distance. And so that's going to be an x value. So if I ask how far will it have traveled, that's asking for the x value. So how far? What is the x value when it hits the ground? Well, my x equation, remember, x is equal to 165 cosine of 35 degrees times t. So to find x, I need to know t. And we just found t to be 6.04 seconds. So to find the distance that the ball travels, how far it traveled, we're going to plug in that 6.04 seconds in for t. So we're going to have x equals 165 cosine of 35 degrees times 6.04 seconds. And if we compute that, we should get that x is equal to 116.37 feet. Okay. And I've not been too careful with my accuracy, my precision here. I computed that value using the rounded 6.04. If you were wanting to be more precise, you would want to use the unrounded value that we got with the quadratic formula. Okay, but for now, I just want to use that. So x is equal to 816.37 feet. Okay. All right, the third question, what is the maximum height and when is it reached? So again, this is a two-part question. Maximum height, so when we talk about height, right, we're talking about y. And when we see when, remember when is a time, so we want to think about t. So I want to deal with y and t in this problem. I want to know what's the y value at the height, maximum height, and what is the t value. Okay, so the key here is remembering that, again, we have a quadratic equation. So my quadratic height equation is y equals a negative 16 t squared plus 165 sine of 35 degrees times t plus 12. And make sure that you're in degree mode on your technology for all of this, otherwise it will not give you the right answers. Okay, this is a quadratic equation because it's t squared, and it opens down because it's a negative t squared term. Okay, so whenever we think of a parabola opening down, right, it's parabola opening down, the highest point occurs at the vertex. Okay, and just from our pre-calculus knowledge, we know that the vertex happens at x equals a negative b over 2a, which is actually the first part and then the denominator of the quadratic formula. Okay, that's this negative b over 2a part. Okay, it's just giving us the center between the two x-intercepts. Now, we have to modify that a little bit because we're not solving for x here. Y is a function of t. So we're actually looking at the equation t is equal to a negative b over 2a. Right? And we know that b is the 165 sine of 35. So we have a negative 165 sine of 35 degrees divided by 2 times a, and a is a negative 16. So t equals a negative 165 sine of 35 degrees divided by 2 times a negative 16. And again, if we compute that with technology, we'll get roughly 2.96 seconds. So that actually answers the second part of our question. Remember, our question was, what is the maximum height and when is it reached? We just found the when. It will happen after 2.96 seconds. The first part of the question was to figure out what that actual height was. And so to solve for that actual height, we need to take the time value and plug it in for t, because our y function, our y equation is a function of time, of t. So let's take that 2.96 seconds and plug it in for t in our y equation. Y equals a negative 16 times 2.96 squared plus 165 sine of 35 degrees times 2.96 and then plus 12. Okay, so I'm just putting that 2.96 in the place of all the t's. Okay, and again, I'm using the rounded answer, which is going to lose some precision here. If you wanted to be more precise, you should use the unrounded answer for t. But I'm just for this illustration, I'm going to use the rounded value. If I compute that on my calculator, I use technology here, I will get a result of 130.63. And so that is the y value, which if you look at the units in the problem where everything was in feet and seconds. So this is 130.63 feet. That's the highest this ball will ever get. And it happens after just short of 3 seconds. After 2.96 seconds, it will hit its maximum height. And again, it will hit the ground after 6.04 seconds, in which it's traveled a horizontal distance of 816.37 feet. And so that answers all the questions that we needed to work with. Again, for the most part, all these problems are very similar. You're going to have to figure out when it hits the ground, how far it travels. And the key to all of that is that they have to have a common, the distance and the height always has to use the same x value, or the same t value.